Hello everybody, this is Programming Mess. Today we will cover one of the most essential topics in Python, variables and the different types of data they can store. Variables are names we assign to pieces of data in our code, so we can reference and work with them later. In Python, variables can store many kinds of data, from numbers to text to more complex structures like lists or dictionaries. First, we have integers. These are whole numbers, both positive and negative, without decimals. What do I mean? I mean, we have a variable, for example, called age. We created a variable with a value of integer, which is 25. It doesn't have any decimals. So now I want to do some operations with it. I want to say a equals to okay, now let's run the code. As you can see here, we have these outputs, and that's completely true. Next is float for representing decimal numbers. So I want to declare a variable called price and attach a value of 29.99. So now we declared the variable called price. Very cool. Now we can do the same operations with this variable. Let's run the code now. As you can see, we did the same operations with this variable. Now we can also have operations with some decimal numbers too. We can kind of have decimals here and here, for example here, and when we run, we can see that we did the operations with both integers and floats, and that's very good. Now, what are strings? Strings are sequence of characters often used for text data. So what do I mean? I can store a name in a variable. I write name equals to Alice. I can use both double quotations and single quotations to declare a string variable, and I prefer double quotations. I write Alice and I print it. Let's run the code. It says name is Alice. Very good. Okay, we can do some operations with this string variable. We write the name of variable, we write name, and we put brackets, and here we put numbers. What are these numbers? We can put any numbers here, but only integers, so numbers without decimals. But what are they? What do I write? Zero here, we don't have zero. This is the first one, this is the second one, and we go here, this is the fifth one. So what do I mean by zero? In programming, sequence of text strings start from zero. So we say this A here, this letter A, has the index of 0, and this L, this letter, has the index of 1. This has index of 2, and this one 3, and this one 4. So the fifth one has the index of 4, and the first one has the index of 0. Now we run it. As you can see, it prints A because it's the first one and its index is 0. We sliced it. Okay, now if I want to slice this text, slice this string, what do? I write the string, I write the index 0, for example 3. Now it printed L from Alice. Okay, good. Now we slice this string. Okay, now I want to add some string. what do? I write name. Okay, let's run the code. Here we said name, which is Alice, plus is, which will be Alice is, and plus str, which is short form of string, which we use to program to code that to say anything in this parenthesis is string. So we say Alice is 25, as you can see here. If we remove this, what will happen? Let us see. It will give error because it's a type of integer and these are type of string. So it has to be a type of string to be added to the other strings. Next one is Boolean. If we write here, I declare a variable is online equals to true. So now we created a variable of Boolean type or bool, which we use for conditional logic or logical conditions in programming and in codes. Now we want to say Alice is online. What do? I say if is online if is online equals to true, say, now I'm using formatting, say name is online, and if Alice was not online, say else print is offline. Okay, let's print it. Says Alice is online. Why? Because we have set the value of is online to true, and if we say it false, it will say Alice is offline because the state of being online is not true here. Let's go to the next variable types, which are more complex. Lists are ordered collection of items, like a sequence of numbers or strings. Okay, I want to say jobs equals to programmer doctor, for example, and teacher. Okay, now I want to say that Alice is a programmer. I say print Alice is a, I use jobs, and from jobs, now if I print this will give me the whole of this list. I don't want this. I want just programmer. So what do? I again want to access to its elements. I put brackets, and again, like strings, its index starts from 0. So programmer's index is 0, doctor's index is 1, and teacher's index is 2. So I put 0 here and I print it. It says Alice is a programmer, and that's cool. Now I want to add another job to this list. I want to say jobs.append engineer. Now I want to print the list. Okay, now we have programmer, doctor, teacher, and an engineer, which is appended to the end of this list. Okay, now I want to remove some things from it. I want to remove jobs dot remove programmer. and it will say doctor, teacher, engineer. Programmer is not there, and that's good. We appended, we added, and we removed the elements to this list. Okay, let's go to the next variable type, which is called tuple. Tuples are similar to lists, but they are immutable, meaning they cannot be changed. Okay, we write dimensions equals to parentheses 9020 and 1080. Okay, now we have this tuple. We created tuple. Parentheses are signed for tuples and brackets are signed for lists. Now I want to access to the first dimension. What do? I say print dimensions, again brackets and index of 0, and I print it. It says 9020. If I want the second one, I should say print the second one, and it's 1080. That's cool. Okay, now I want to add something to this dimensions. Is that possible? We said it's immutable. Okay, let's try. I say dimensions dot append, for example 768. I print it. It's a tuple object, has no attribute append because it's immutable. If I type dimensions 0, I cannot even edit anything. If I type dimensions brackets 0, set it to 768. If I do it, it's a tuple object does not support item assignment, so it's not editable. Even I cannot remove it, so it's immutable, and that's cool. Let's go to the next variable type called set. Sets are collection with unique and unordered items. Okay, let's see. We say unique items equals to curly brackets 1 2 3 4 5. Now I want to print unique items. As you can see, we have this set here, and now I want to add something to this set. I want to say unique items dot add 6 and print unique items. Okay, let's see. Now there is it. We have 6 here. If I want to add 3 again to this set, it's same as here. There is no duplicate of 3 because, as we said, these are unique. This set is a collection of unique items. It doesn't support duplicates, so I can remove. For example, I remove 2 from here. It says 1 3 4 5. There's no more 2 here, and we removed something. And we removed 2 from this collection, and that's very cool. Okay, let's go to the next variable. Dictionaries. Dictionaries store data in key value pairs, allowing quick data access. Okay, I say person equals to curly brackets name is Alice, comma age is 25, and job programmer. Now I created a dictionary. I want to access to its elements. I want to access to its keys and values. These I have typed in the left: name, age, job. These are keys to access to these values. Okay, what do I mean? I mean we write print person name. Okay, it says here Alice. If I write here age, it will print 25, and that's very cool. So we can access to these data. If I want to add anything to this, I would say person brackets city is, for example, New York. I print person. It says name Alice, age 25, job programmer, city New York, and that's cool. So we add something to this, and if I want to delete anything from it, I simply say del person name. Now we don't have name anymore here. We have age and job. That's cool. Okay, let's go to the next variable type called non-type variables. Non-type represents the absence of a value. It's often used to initialize variables or indicate no results. For example, I type here result equals to none. And if I print it, result, the value is none. As you can see here, none. So we can use it in another ways too. Like I can say if result equals to none, come and say print there is no results. Else, if result is not none, print result is result. If I print it, it says there is no results. If I change it here, if I adjust it, result is, for example, 12. Say result is 12. That's very cool. Okay, we also learned non-types. Let's go to the next variable type called range. Range is used for generating sequence of numbers, often in loops. So let's say range equals to range of 10, for example, and I come here and I say print range. It says range 0 to 10. Okay, as you can see, we don't have 0, 1, 2, 3, 4 to 10. We just have range 0 and 10. Now if I do this in this way, I say for I in range print I, see what will happen. It will print from 0 to 9. It won't print 10, but it will print from 0 to 9. So this range is used for memory optimization. Here we have 10. It might be 1000, it might be 10,000, 100,000, million, and here it's not creating a list of items from 1 to 100 million, from 1 to whatever is it. It just creates a range, and it's very useful for memory optimization, and that's cool. Okay, now let's go to the next variable type called bytes, and also byte arrays, which are kind of different variables. Bytes are a sequence of bytes. Okay, and byte arrays is a mutable version of bytes. Both are often used in files or binary datas. Okay, let's see. Okay, now I declare the variable called bytes data, and I assigned hello to this variable, and it's as you can see, I have typed B and its color is blue here. It's a sign of that this variable is a kind of bytes. So if I print bytes data, it will say that B hello, which is representing that this variable is kind of bytes. It's not string, it's not normally string. Okay, so let's go to the next variable, which is bytes array. I say bytes array equals to bytes array, and that's for example 5 here, and I say print bytes array and print it. It says byte array and this. So as you can see, this have converted to a bytes array, and this is used in binary data, so it's now a binary data. Okay, cool. Now let's go to the next variable type, which is called frozen set. Frozen sets are immutable sets useful when you need an unchangeable set. Okay, what do I mean? Let's create a frozen set here. Frozen set equals to frozen set parentheses and brackets 1 2 3. Now we print it. We print frozen set. Okay. Let's see. It says frozen set, and as you can see, these are signed for curly brackets, which are signed for sets, creating set. It says it's a frozen set. Okay, now I want to add something to this frozen set. Can I do that? Let's see. I say frozen set dot add, for example, 6. Let's see. It says has no attribute add, so it's immutable collection of set. It's immutable kind of set, and that's very cool. Okay, let's go to the next variable type called complex number. Complex numbers have a real and imaginary part, often used in scientific calculations. Okay, let's write comp num, for example, equals to 3 plus 4j. And now I want to print its real number. I mean, you will see comp num dot real. Let's print it. It will say 3. I want to do the same, but print imaginary number of it, which is 4j, and that's cool. Now we can do another thing here too, which we can say conjugate. Yes. Now if I print that, it will say 3 minus 4j, and that's used in advanced mathematics for scientific calculations. Cool. Okay, Python is dynamically typed, so you don't need to declare a type. However, sometimes you need to convert types, especially between numbers and strings. Let's see how we can do that. I showed you, we have here age, and we have here name Alice. When I want to say print name, which is Alice, plus is plus age, we will have here error that it says it's integer and these are string, they can be added together. So I use str here, it's a built-in function, and I convert this age 25 to a string, so I can use it with strings. and now its Alice is 25. Now if I say age equals to a string of 25, now if I say print age plus 2, as we did the operations before, we will have error here that says it's a string, it's integer, it can't be added, it can't be increased. So what do we do here? Here we say integer int, and we run it, and it says 27, and we say to computer that it's integer, it's not a string. We have declared it as a string here, but here we say it's integer. We can do the same for float too. We can say float age plus 2, which will make it a type of float. Now I can also get the type by printing print a print type parentheses and age inside of that, and it says it's a kind of string. If I remove these quotations here, it will say it's integer, and that's very cool. Okay, and there you have it. Python offers a wide range of variable types to fit almost any need, from basic data types to more complex structures. Understanding these will allow you to store and manipulate data effectively in Python. If you have found this video helpful, give it a like and subscribe for more Python tutorials. Leave a comment if you have questions, and check out our next video to dive deeper into Python operations. Thank you so much.